This video is part 3 of 2.2 linear inequalities. We're going to look at tripartite inequalities. Interval notation will be a little bit different because we have kind of different sides we're looking at. If A is less than X less than B, then the equivalent set of numbers in interval notation is AB. And that's where it kind of starts looking like a point, right? It's a little more clear if we have the equality symbol and we have brackets, but when we just have the curved parentheses, it can start looking like points. So keep in mind the context, and it's not going to be the same thing as when you're doing an XY coordinate system. This is just still, we're just graphing on like a number line, right? Just the domain. So for example 2.13, solve the inequality, graph the solution, and write the solution in interval notation. So here's where we have an intersection is another way of thinking of it, is the word and we would use the symbol, looks like an upside down horseshoe, and we would say and that's called intersection. So keep that in mind. And I'm going to show you a couple of different ways to solve these. I'll do part A with one method by splitting it apart. And for B, I'll do it all three together at the same time. And I'll also show you how to test your answers. We didn't look at that before, but to verify if your answer is true, you just pick anything in that interval and plug it in and see if it works, if it's a true statement. So you might want to go back and look at, for example, let's just go back up here. If we looked at part C of the workbook from before, and we end up with X is less than -2, we could actually pick anything in there that's less than -2. Like we could put a -3 in and solve it and see if it works. And if it comes out true, it's true. So I didn't go through any verification process with those. Maybe I'll do that at the end of this tripartite video. For D, we could actually do it very quickly because we could look at X is less than or equal to 1. We could pop 0 in, and if 0 works, because that is less than or equal to 1, so we could put 0 in here and we would get 4 thirds. If we put 0 in for X, right, and we would get 4/3, and if we put 0 in on the right side, we would get 1/2, and 4/3 is in fact greater than or equal to 1/2. So we're not going to get an equivalency like you would, checking for equations, but you get a true statement, and that's what we're looking for. So I'll work through one of those at the end. So back to tripartite inequalities. Let's solve the inequality -22 less than or equal to 4x plus 2 less than 18. So I'm going to split it apart. -22 less than or equal to 4x plus 2, and, or I could use the intersect symbol, 4x plus 2 must also be less than 18. So sometimes it's just easier for people to work with it that way. It's up to you. And then, so I'm going to do the one on the left, -2, subtract from both sides, or -2 from both sides. See? And so we get -24 less than or equal to 4x, and then divide by 4 on both sides, and I end up with -6 less than or equal to x. And I'm just going to leave it that way for now. I'm not going to get the x to the left or anything like that. And you'll see why in a minute. So on this one, I'm going to subtract 2 from both sides. And then I end up with 4x less than 16. Divide both sides by 4. And I end up with x less than 4. Okay, so now you can see where this x is in the middle. So I have and all carrying down there. So when I graph it, I'm going to want to write in my -6 down here and my 4 up here. And 0 somewhere in the middle there. So then we want to include the -6. So we have -6, and then we have everything greater than -6. So I'll write that kind of above here. Okay, x can be bigger than -6. Then on the other one, I'm going to do different colors so you can see we have 4, not including 4 though. So it's a curve. And we have everything less than 4. So what we're looking at is the intersection, the overlap. Okay, so we just want the overlap, okay, of the orange and the purple. So our answer ends up being -6, including -6, comma, 4, not including 4. So this is the answer in interval notation. This is my graph. So for the graph, I would just graph this part. I'll do it in black here. This is my answer for the graph. This is my answer for the interval. And to write it this more formally, I would write -6 less than or equal to x, and then x, I don't want to rewrite that, just x is already there, less than 4. So those are all the ways I can write the answer for that. So B, I'm going to do a little bit differently. I'm going to take a shortcut and do it all kind of simultaneously as I work instead of in separate pieces. So if you're comfortable with that, go for it. Okay, so here's -8 less than 3x minus 2 less than or equal to 13. And so I want to add 2 to both sides. Gotta isolate my variable term. Or actually I should say all pieces, right? And then I end up with a -6. I'm just going to kind of move it over a little so it's out of the way of the other one. And then I'm left with 3x in the middle there. And then less than or equal to 15. Now to isolate the variable, I can divide every piece by 3. And I end up with -2 less than x less than or equal to 5. So it kind of works out really nicely for me. And then to graph it, I know I need to have -2 there. I need to have 5 up here. I'm going to include the 5 and not include the 2, and I want everything in between them. And I would have interval notation as -2 with a curved parenthesis up to 5 with a bracket. And those are all the ways I can write my answer for that problem. So it's a little quicker when you streamline it, but sometimes it's just hard to keep track of doing that for people. But this part A could have been done that way also. So maybe try that with the shortcut method I just showed you and see if you get it right. Right, so I do want to make sure I show you how to verify your answer. So we're going to write that down below here. I can pick anything in this interval, anything that would be true for x. So 0 works. And I'm just going to plug 0 into my inequality. So my original inequality was -8 less than 3x minus 2 less than or equal to 13. I'm just rewriting it so it's clear what I'm doing. Then I'm going to pop in the 0 times 0 there for x minus 2 less than or equal to 13. And what I end up with is -8 less than -2 less than or equal to 13. And so as long as that's a true statement, which it is, then my solution worked. It's valid. I'll show you one more up here if we want to scroll back up, or you can go back to your worksheet. But we have x plus 3 less than 3x minus 7, that classwork from page 28, part B. And we ended up with x is greater than 5. So we can't pick a 0 just to pop in there easily, but we can pick any other number. We could pick 6. That's bigger than 5, so that works. So we would do x plus 3, I'm just rewriting it, less than 3x minus 7, and I'm going to let x equal 6. So I would do 6 plus 3 less than 3 times 6 minus 7. And then I end up with 9 is less than, that would be 18 minus 7. So I end up with 11 there. And 9 is less than 11. That's true. So my answer works. All right. So thank you for watching and have a great day.